Chuck Niemeyer. I'm with Innovative Laboratories. We're the company that installed the casework, fume hoods, etc. for Mid-Pacific. And what I would like to do is run through some of the features of the product and help you both in the maintenance and also in its use. First of all, looking at standard metal cabinet, which we have here, and most of them are all structured the same with pull-out shelving in them. If you, it might be a little tough to see with the camera, the shelving is adjustable vertically. And in order to make an adjustment vertically, there's two little tabs on the side. If you push the little tab in and lift up on the shelf on both sides, you can lift the shelf out completely. You'll see on the side, if you can focus down in here, the two light neutral tabs there. These hook into the little slots that are along the side here. There are accompanying two screws in the back. And those two screws, when they're removed, you can take this glide and you can move it any place you want vertically along or up or down along this path. Putting the shelf back in, there's some little clips in the back that hold it there. It should just snap right back in place and slide back in. If you do need to get access primarily for maintenance to the back of the cabinet, there'll be two screws in the back rear of the, or the bottom rear of the cabinet. And removing those screws, you have filler panels that easily slide out for access into the back. If it becomes necessary to make adjustments in your doors, for some reason or other after a length of time, if students maybe lean on the edge or people use that to support themselves to get up and down, they can loosen a little bit and maybe slide down a little, whatever. There are two screws top, two screws bottom. If you loosen those, you can slide the door body up and down, and then you can tighten them back up and retain your adjustment. These have all been tightened down. They should remain where they're at as they are now. The handles, just simple removal if for some reason they need to be changed. The cabinets basically are universal in structure. On the insides here you see some additional drills here to accompany other type of features on this. If you wanted to make a doored cabinet out of this, you could do this. If you wanted, these are actually drilled. If you wanted doors on the bottom and a drawer on the top, that's the structure here. So there's a lot of versatility in these cabinets if you ever do need to make a change with them. Cleaning the cabinets, I would use just common detergent and water and maybe a little furniture polish occasionally just to help protect the surface. Mark, any questions about the base cabinets?
What happens if they get scratched or dinged? What kind of problem would that cause, or what do we do?
There's most of these have a base coat underneath them with a powder coat over the top. If you scratch this, the gray color you see here, you'll see a lightish, sort of a light neutral color there. And we're going to furnish touch-up paint to the school that they can utilize to touch those areas. But it would take a very, very deep scratch to affect the integrity of the cabinet to where chemicals or whatever, or your salt air here would have a negative effect upon them. The one thing I didn't mention here, occasionally these little closures will loosen up after a length of time, and all you have to do is just loosen the two screws and they have vertical ability to adjust up and down. If for some reason you might get some alignment where one of them is out further than the other mating component is right up here, and again there's two screws up underneath here with a stop, and this piece will slide back and forth for adjustment as well. They all should be initially adjusted to be perfectly square or very, very close to being square.
What about lockability of the cabinets?
If for some reason or another this cabinet here, somebody would desire to make it into a locking cabinet, looking along the inside, I don't know if you can see the little indentation, is pre-punched on the inside for a lock mechanism. So it would be entailed, would be purchasing a lock mechanism and then drilling a mating piece out in the front. The mating piece in the front will be round. This piece here is not round. It has two flat sides to retain the lock, because the lock cylinder has two flat sides. And it's relatively easy to do. In this case, if you do this with a double-doored cabinet, you'd either have to lock both sides, put locks on both sides. More than likely, you'd put a catch up in here, snap catch, that you would release on one side and just have a lock on the other side. All the cabinets that you have purchased all have pipe chases backing behind. I don't know if you can see from the back side. They'll all have a 6 or a 7-inch chase back in here. Cabinets are 22 inches deep, which allows movement of plumbing, electrical. If you ever need to make changes back in the back, they're readily accessible to do that. The countertops that you have purchased are a two-part epoxy resin. It's a homogeneous material all the way through. The two-part epoxy uses a very, very fine silica or sand substrate, and it is, consistent all the way through. You will find that if you do get some fine scratches, especially in the initial time when you scratch them, you're going to find that you're going to get a white line appear where the scratch occurs, and the white line is due to you scratching or touching the surface of the silica. There are some ways you can clean these up a little bit. For some reason they tend to heal themselves a little bit, especially if I wouldn't use any abrasive on them. A lot of times we'll use a product like a WD-40 or something like that, and for some reason it seems to take the luster out of the scratching, etc. For cleaning these countertops, I normally use just standard soap and water, and we recommend also, I'd say, depending upon use, maybe once every 3 months or 6 months, end of each semester or whatever, come in and again use a product like a WD-40, give the rag very, very oily with it, rub the surface down, and you don't want a whole bunch on there, but just so you get a little oily sheen on there. Leave it set for about 30-40 minutes and then come back with a soft cloth and buff that surface back out. And you'll end up with a top that is very, very close to original. If for some reason or another, something would happen, there's some susceptibility maybe in the corner, somebody hit a corner real hard with a cart or something like that. They are susceptible to being chipped if that would happen. I shouldn't say susceptible, they could be chipped. They're not really susceptible to that. If that does happen, we can get little repair kits for you on a two-part type of a setup that you can mix the materials together, and we have a person in Honolulu here that would be very adept at coming in and fixing those for you. But we don't envision that happen, but it could possibly happen, whether it be a case of vandalism or something like that would be more likely than anything else, with the exception of the students here at Midpac.
Yeah.
A couple other things about the countertops: they are extremely chemical resistant. Some of the things that will appear negative with these, water spotting. If you have high mineral water and you allow it to sit on the countertops, they will spot after a length of time. I would caution also, if you use very, very caustic chemicals, acids are very, very strong bases, even some in their dilute state. If you set them on you pour them out of a gallon bottle or a jug or something like that, and you set them down on the counter, if you don't remove them within a length of time, if you leave them set a length of time, and that acid accumulates around that little serrated base, it will etch the countertop. And so it's imperative that you do a good job of housekeeping. Even though these tops are very, very chemical resistant, abuse of that type would not work well. So I would suggest using something like a trivet or something underneath those type of materials, or some type of protective material to prevent that etching in the future. One other aspect of the countertops, they can be susceptible to damage by extreme heat. For example, if a Bunsen burner was tilted over and flame allowed to hit, after about 30 seconds or so, it will soften the surface to where actually the resin actually could be removed. It's, again, it can happen. I have not seen it happen very often. In most cases, it has to be a blatant attempt to cause damage, almost more than anything else. You could tilt a Bunsen burner over, but I really have not seen that happen, that somebody would not be attentive to what has happened with it. But extreme heat can be negative to something like this. If you would have a heating device that for some reason doesn't have very good insulation in the bottom or something like that, I would suggest blocking it up so you get air movement underneath it, so you don't develop excess heat. Most ovens, incubators, even muffle furnaces can work right on the surface. There shouldn't be any problem. But in some cases, maybe if the legs have been removed for some reason in the box that's directly on there, you could have some damage. Any other questions about the resin tops?
If there is some kind of extreme damage, is there any kind of filler or fixer that can be used to at least bring it back to a fairly level surface?
There are some things that could be done. One thing would be the possibility of even cutting out that area and removing it, if it's not too large, either with a hole saw of fairly good size where we can put a plug in there or something like that, or even physically cutting out a piece and putting an area in there. More logically, what would happen if something like that does occur, would be removing a section of the top, cutting the seam back out. These are your epoxy together, cutting the seam with a diamond blade and then removing that section. And it could be a section, you wouldn't have to, if some of these are close to 9 feet in length, you wouldn't want to replace a 9-foot top, but you could replace a 2-foot piece, you know, if you had somebody that knew what they were doing.
Do you folks sell the resin for like scratches or?
We do have, you might want to hit the camera on.
Yeah.
That I will go about and get some of the material. There is a 2-part epoxy, black epoxy, that doesn't have the silica in it. And you can take that material. I would not use them on common scratches because it'll tend to dull and sort of spread on the surface. But if you'd really get a gouge or something like that, I'd have a tendency to mask off as much of that area or closely to the shape of that gouge that you have in there. Use this 2-part epoxy, fill that area, and then I'd use a hair dryer, which I use often. And I'd use a hair dryer and get some heat on there. It'll help it cure in a pretty fast time frame. As epoxy resin is hardening, it is actually soluble in water. So the other thing you can do if you do mask it off is once you have it all masked off and the area filled is take a putty knife and draw it down across over the material so it gets almost a very, very flat surface. It'll leave maybe you know, a 64th or so type of a ridge around where you've applied it, the thickness of the tape. After you've set it up and it is dried, or almost dry, I shouldn't say dried, after it's almost dried, if you pull the tape off at that time frame, and then I would take like distilled water, put your finger in a little distilled water, and just feather around the edges and it'll smooth it out. And it'll also give gloss to the surface, which, and I use DI water because sometimes, again, if you have iron impurities, sometimes it can cause some discoloration in some of the resins. So that's a very good question. We did discuss it earlier, and I think it's a, you know, it's a good point. I mean, these are more repairable than what people think. But, you know, most people don't want to go to the trouble of doing that. But it's a fairly malleable product. We have, I think, 5 fume hoods on this project. There are 4 of this type, and there's one special hood over in biology, which is a dual-sided fume hood, which we are probably not going to put on the tape today. Anyway, standard fume hood that has a constant volume of air going through here when the blower is on. Right now, with the sash closed, if the fume hood is running, the air will go up underneath the airfoil and then come down over the top of the plenum up here. So it constantly will flush out whatever materials are inside that fume hood. Once the sash starts to open, it starts to block the bypass up here. It cuts off that upper plenum as far as supply air. As it slides up, more air comes through here, more air comes, you know, feasibly down through the bottom here. The fume hood suggested operation, if you're running an experiment or something like that, is in this position with the sash closed. This offers the optimum protection for students, the operator, or whatever. A lot of times you can't operate a fume hood with the sash closed. So you bring it up, you'll notice there is a sash stop on the side of the hood here set at 18 inches, which is considered to be the optimum opening. At this position, you can work on something that's inside of the fume hood, still retain a fair amount of protection for the, at least for your head area, something like this. The times when you do need to set up something in the fume hood, you can bypass the sash stop, you can move the sash all the way to the full open position. This is not an operating position for the fume hood. Your face velocity will drop down dramatically here till you're in a safe situation. So you want to make sure, and it is sometimes when you do a lot of work in the hood, it can be inconvenient to do that, but you need to operate it in this position, especially with students around. At no time should anybody allow to put their head in this hood when it's in an operational situation, because it's not a safe environment in there. The inside of the fume hood, if you look in the back, it has 2 non-adjustable baffles. And behind these baffles is a gap or an air opening of about approximately 2 inches in depth. All the fumes either go down underneath this baffle, in between this baffle, or they go up in through the top of the hood. There's an opening up by the light area. So one of those three areas. The reason for the baffles: removal of heavier than air gases. If for some reason you have apparatus or equipment across the bottom that is starting to block this opening, it moves through this area here, or for gases that are coming off of reactions or whatever, very easy to get through this bypass area. For gases that are extremely light, or if you have a reaction is rapid enough that they're kicked into the upper part of the plenum, they'll be pulled out through the top. The actual exhaust of the hood is through the top of the hood. The access to the sides, you'll notice the side panels here, slip in and out. Gives full access to the valve bodies, wiring, whatever other materials are inside the fume hood. They slip back in. You'll notice plugs on the sides of the hood. If you ever add any other features or fixtures, we have a cold water fixture. If you'd add gas, air, nitrogen, anything like that at some future time. They're all pre-punched for those on both sides. They're also pre-punched in the middle. They're also pre-punched in the back if you would ever put a gooseneck back there or another water fixture in the back. The insides of the hood are made out of epoxy resin. This is a modified epoxy resin, pretty much identical to what your countertops are made out of. Very light in color, very, very cleanable. If you ever do get damage to these liners for some reason or another, very easily removed, and a new liner can be put in. If you need to access any of those materials, you'll notice the little buttons or caps here. These are little snaps that fit over the top of a screw. Readily pop open, and there's a little screw head back in behind there. You could remove this entire fascia panel if you needed to. Access for maintenance of the hood, the upper part of the hood, to access the light fixture. You notice the panel up above the sash up there, easily removed. It's a fluorescent, standard fluorescent fixtures up there. You'll have maintenance or somebody will need to access them through up there. This size hood will use standard 4-foot bulbs. So it's really, it's a very easy item to use, a very easy item to replace. On the front of the hood, you'll find this device up here, which is the vacuum breaker. And the vacuum breaker is intended to keep siphoning of water or fluids coming back into the water system. You may, under some use conditions or whatever, might get a little dripping or leaking back up out of this fixture up here. I wouldn't be overly concerned unless it consistently drips. If it consistently drips, the seal, a little nylon setting up in there, I shouldn't be calling it a setting, it's a little fitting that's up in there, nestles down when the water pressure is off, and if that doesn't seat, you might get some dripping around there. And what you'd have to do is maybe pull it out, clean it up. If not, they're very easily replaced. There's 2 screws in the top of this thing. Take them out, that little nylon fitting is right there. Easily replaced. The hood that we have here, and all the hoods are only equipped, I'm not sure about yours in the other building, but this one here is equipped with cold water only. GFI electricals. If you're going to run electrical inside there, we really recommend you bring the cord up underneath the airfoil here, as opposed to bringing it across the top, because it doesn't allow you to close the sash completely. Operation of the fume hood. I don't know if you can see it with the camera here. The way the sash is set up here, there is a recessed trough in the entire inside of the fume hood. The front recess goes back 6 inches behind the sash. The intent or the purpose of this is that when you run an experiment or anything in the hood, you want to set whatever you're doing a minimum of 6 inches behind that surface, or behind this surface. The further back you put the experiment or whatever you're doing in the hood, the more effective the hood will be at removing the materials. What happens if you stand in front of the fume hood, you'll have air moving in here, hopefully approximately at this height at around 100 linear feet per minute. At 100 linear feet per minute, if I stand in front of this hood, the air is going to come around my body and is going to create turbulence in front. It starts to calm down approximately 6 inches inside that sash. If I have it closer than this, what it's going to do is be drawn along my body cavity. It'll draw up my body cavity and into my breathing area. So that's the intent of driving this area back there. It's very, very crucial to do that. Any questions, anything we haven't covered?
We're live.
These fume hoods are set up with a blower called a strobic blower system. And in this building, I think they're all hooked up to one blower. I think you only have the one hood over in the other building with the one. Is there one hood over there?
There's only one hood over there.
One hood over there. It has its own separate strobic blower, whereas here they're all hooked into one blower setup, which is very, very common. What happens as the air is pulled in here and leaves and exits, it's very, very important with fume hoods that you get a dissolution or dilution factor very, very quickly in the atmosphere. Not only quickly, but very vertical. You want to drive that air very, very high as quick as you can. So the strobic system, instead of pulling enough air in order to thrust it all the way up, instead of pulling that air all out of your laboratories, what it does is, and I think it's around 75% of that air actually comes off the outside along the roof line itself, and is pulled up into that blower assembly with like 25% coming out of the hood, the 75% out of there, which gives you now 4 times as much air to disperse that material. And so it'll throw a plume very, very strong up there. Very, very essential, because in your building, as in any other building, you're going to have areas where you're going to pull outside air in for your makeup air. You don't want to be pulling back in what you just kicked out. So you get it out, disperse it, the breezes will move it away. It's an extremely good system. It's considered to be the best system that's out there right now.
Can you just briefly talk about 2 things? One is how the sash is controlled by that stainless steel cable, just so that people understand what's driving it.
Yeah, the sash has a 2 point of attachments with a braided stainless steel cable. The cables go up. There's a pulley assembly in this corner. There's another pulley assembly here. The cables then go back to the back corners. Another pulley assemblies. They come back to the middle, and back to the middle is a heavy sash weight. And that's what drives this thing. The sash is very easy to move. Should be a one-handed operation. Moves easily up and down. Access to those the stainless steel cables should last forever. We do have some times where they do fail, but they should last forever. If they have to be replaced, it's probably best to have somebody that knows what they're doing with them. The sash is also unique in the fact that if a cable breaks, if you have a sash and one cable would break, it's not going to come down. You know, it's old fume hoods years and years ago. I don't think you had one in your prior facility, but if you get fume hoods that are 30 or 40 years old, you'll find they had what is called a guillotine feature. Oh. If the sash cable would break, down it came, and it would be very, very negative.
So is there any maintenance at all that we need to do with the sash?
No, there really shouldn't be anything at all. It has nylon glide systems on the side, which just should last forever. There really shouldn't be anything that would be done other than occasionally wiping down the interior just to keep it clean. The countertops, the same material as what you find in the countertops out in the rest of the laboratory. In the back of the fume hood, you'll find a vent pipe coming up the back, which is approximately 2 inches up above the surface, and that's sealed from the surface so nothing can get down along that vent pipe. That vent pipe goes down into the acid storage cabinet below, and it's venting the acid fumes up into the back of the hood.
Is this always on?
Your system, I don't think, is intended to be operated in an on position, and it's not set up for a downtime setting. In other words, it's not set up that if you're not here or not operating or whatever, that it shuts down to a very, very quiet mode and still exhaust. So what you're going to have is a static setting here. I think from talking to Mark, I think most of your type of structure, the way you're going to use your laboratories, these are not going to be standard storage devices. What they're going to be used for is to store materials that you're actively using in a time frame, in a given time frame, and it might be a week or so. It doesn't have to be, my gosh, I got to get stuff out of here tonight because I don't want to leave it in there. But if your system is not active, you do not want to leave, especially open materials. And even a closed bottle of acid, especially if it's been open, that seal's been open, will constantly emit fumes. They're going to go right through the lid and everything else. So as long as we're talking about the acid cabinet here, you'll notice it has a poly liner all the way. This used to be a cement board type of material, And your manufacturer of this product actually puts a poly liner. They're also the only one that puts a full poly tub in the bottom, and it's all 4 sides around and the back that's continuous of the poly material. So if you do get a spill in there of some sort or another, it'll be containerized as opposed to getting into the cabinet and corroding the cabinet. It is removable if for some reason you need to get it out of there. It has a series of screws. Interestingly enough, the screws with the plastic material that is there, as they go through the material, they seal. So it isn't like the chemicals are going to work their way around the screws and get back in there. But it's an extremely good liner. One thing that I need to caution you on is that this is a sort of an expandable little type of a roller catch in here. These sometimes do fail. And I talked with Mark, we're going to send some of them along, and I think probably, I thought about sending them to maintenance, and I'm probably going to send them to Mark, so you keep them in, so they don't disappear and somebody forgets what they're for. But we'll send some common materials like these and some of the other roller catches and some handles and this type of thing, because these can be broken. And usually they don't break after they've once been in. Usually it's in transit or whatever, they get racked around or something like that they do break. The solvent storage cabinet, which you have over here, is a very unique cabinet. If we open it up, you'll find that inside it has a tray on the bottom, again to contain spills. You have a ventilated shelf in here to allow free movement of air. You'll also notice that the cabinet is not vented. It depends upon local regulations or whatever. Kiwani and I do not recommend venting a solvent storage cabinet in the fume hood. It's putting the spark too close to the combustible material. This cabinet is sort of interesting in the fact it is also a patented material that if you close that door, whoops, this is not working right at the moment. I may have to hook that back up. It is set up, and we did it with the other one, is that the one door will not close without, this one should stop, and I'll check that out and make sure that does work, but it should not be able to close itself until the other door is closed. What it allows you to do is when you go get something out, like a bottle of solvent or whatever, is that you can reach in with both hands, get the bottle of solvent out. Once you step away from the cabinet, release the doors, they'll automatically close, and they'll automatically close in order. And it was good to have this happen now so we can get this fixed before the one in the other room works great, but we'll get this one fixed as well. The fume hoods have not been calibrated yet. You'll notice along the side you have an air alert alarm, a little sticker on here that I'll be pulling off once I do the calibration on there. If for some reason or another your velocity of your fume hood, or it's actually the velocity falls below what is considered to be a safe level, the alarm will go off, and what you'll hear is this, and the little red light will come on, and that will stay on. That happens to be a test pattern, but it will stay on until somebody comes in and says, hey, I've got a problem here, this needs to be fixed. And so what you can do, if you want to get rid of the obnoxious sound, is push the test button and it'll put it into a norm type of setting. But I shouldn't say it'll put it in a norm setting. What it'll do is get rid of the audible part. The red light will stay on, so you come in there and see the red light is on, or you've shut it off, you'll know it's in an unsafe condition. Now, if your system is not operating, when I have these things working, if your system does not operate, so at the end of the day, or when you get done running your experiments, you have a switch on the wall, you shut your blower off. When you shut that blower off, this alarm is going to go off. Well, you'll need to come over and hit your test reset and silence the audible part of that alarm. You come back to run your hood the next day or whatever, once you switch that blower switch back on, the air starts moving through there, it'll move back into a normal setting. And it'll be ready to let you know if something is wrong. Again, adjustment on this, if I would suggest, and there should be somebody around on the islands there that will do that you have somebody come in maybe once a year and do just not a calibration. All they're going to do is certify that your hood is functioning, that it is correctly moving the amount of air that would consider to be safe. You never know when something will happen. Again, your usage is probably not going to be as negative as a lot of areas. You can get in industrial applications. where the impellers up in the blower will actually corrode. And the blower will be going like mad, but it's not pulling the air because it has no surface up there to push it with. Your system also, your entire system is in a negative air pressure. The strobe blowers are exterior of the building, so when they're pulling air, everything's under a negative pressure. Old fume hoods used to put the blowers up in here, and when they would push the air out, they would push it from this point. And if you got a leak in your duct any place, they would push it across the ceilings, into your structure of your building. So it's a very nice piece of equipment. It's state of the art all the way through. Should last for the length of the building.
How do you turn it on?
Well, there's a switch which has been mounted up on the walls up on the side, and the location of the switch is not determined by me. But I think probably the reason the switch has been put in that position is that someone cannot deactivate it readily. You don't want to be running something and have the last kid leaving the class just come by and flip the switch and
That's the switch there?
Yes, it is.
Okay.
It's, again, like I said, I'm responsible for the hood. That's it. I'm not responsible for where the switches are at. But it is a good safe mechanism, and if you're an 8-foot teacher, that's not a problem. Or if you're capable of levitating yourself very readily, it's not a problem either. But
I think Dr. Northern's going to have some words. So.
She was here for the first meeting, so she knows how to deal with it. Would you say it looks like a 5-iron to me?
I told her it looked like about a 5-iron to me. She said she wasn't a golfer, so she wasn't. The one difference, going back to the solvent cabinet, I didn't mention, these are piano hinged as opposed to having the stainless steel hinges that you have on all the other cabinets. Very little adjustability. You basically have to take it out and re-drill it if you're going to do anything else with that piano hinge. There's a cup sink on each side, and it has a little stainless steel grid in it. The cup sink is really intended as sort of a misnomer. It's really not a sink. Basically, it's for dumping of materials, aspirating water through, or this type of thing. If you're using an aspirating type of device or using water as a coolant or something, it's a means of getting it away from there. Also means that since everything is dished through the entire surface, of getting any contaminants or whatever you have and wiping them down and getting them out of there without having to have them contaminate the rest of your area. That's everything I know about fume hoods, unless somebody asks me something that they have a light switch, which is at reachable height.
Except for the indicator.
Yeah.
Oops, sorry.
Anyway, that's, like I said, everything I know about fume hoods.
Okay.
Until I get back to my room tonight and think about the rest of the things I should have told you that you always wanted to know about hoods. One thing, I want to add, as a teacher, you want to make sure, and it's, to a certain extent, maybe, Mark's responsibility too, is that, these are not storage containers. They're not intended to be storage containers of hazardous chemicals or anything like that. You have areas for these items to be stored. That they're used to remove hazardous materials while you're running an experiment or doing, say, prep for labs or something like that. But one other thing I want to, in your lab, Lyle, you have the dual-sided hood. And a lot of people think of them as pass-through hoods. The real intent of that hood, when it was originally manufactured by everybody, was that you as an instructor could go to the positive side of a student and see what they're doing with the lab if they're running one. And as opposed to, it's not a lot of value. You can walk through a door as readily as you can pass something through the hood, but that's the real intent of the hood. And one thing I was also mentioning to Mark, the more people you get around the hood, the less air that comes in here. Interestingly enough, I was running some velocity tests on your fume hood in your room, and that hood, like all the boxes you have sitting around here, the hood is recessed in the wall. There was a countertop here, and it was piled high with boxes. And the face velocity around the corner of that box area was probably about 40% less than it was in the rest of the hood. So just an obstruction changes the effect or the direction that people or the air moves through there. Same way, if you're working in a fume hood and somebody comes walking back behind you, more than likely you can get, even at 100 feet per minute, you can probably get some puffing coming back at you, which, you know, if you have a bunch of students around here, it's not a very, very probably safe thing to do. According to OSHA, if you were actually going to run students in a fume hood, I think they're required to have somewhere around 3 foot of hood per operator. So if you have 20 kids in your lab, you'd have to have, you know, 60 feet or whatever of hood. I would recommend, and you know, you've got great video equipment and stuff like that here. If you're going to do experiments or something like that, you want the kids to see them, I'd suggest putting it on live video or whatever, and live tape, and you know, feeding it back into your screens and stuff like that. I think it's a great way to show that type of thing. It's also safer, so you don't get the students around something that potentially can be dangerous.
Now, on my fume hood, can I have like both sides open and still operate it?
No.
No, one side has to be closed.
Yeah. Your hood is set up, has a lock mechanism in the front on the student side. And then you have to be careful, that lock is you have to push that lock in to lock it. So the cam goes back in behind the little latch that's back there. And it's intended to be locked so students cannot get in through there or do anything. You know, if you're working or doing something on the other side, you don't have to worry about, you know, somebody doing something there. Or if you have another feasibility, I remember when I taught school that my classroom was used by other instructors. So I might be back in the prep room trying to do something. You don't have to worry about somebody coming and jeopardizing your health or their health by flipping that thing open while you're working there. What happens, you know, again, if you're talking about a face opening of 18 inches vertical as optimum height, if you pop your sash on the other side, you're probably really reducing that to, you know, about 9 inches of effectiveness to maintain 100 feet per minute. At 18, running your hood this a little while ago, we were generating pretty much a little over 100 feet per minute, which is really nice operating conditions. The one negative that I found with your hood in there, and I'm not sure, you know, how to address it at this time, on your side, on the prep side, the sash works extremely well. On the other side, it does not function very well in a one-handed operation from an unbalanced condition. It does not have this type of a setup in here. It has a two-handle type of sash. I think, as best as I can tell, what has happened in that area is those walls have been pinched in too far. There wasn't enough give in the wall for that hood, so it's just a little tight. And I talked to the installer when he put it in. He said, you know, he was able to compress it out for a while, but you know, given length, he just can't hold that, you know, dimension. So it's not bad, but it's still, you really need on this side probably to effectively, and it does have two handles. You know, different than this hood has structural integrity all the way around. It has an airfoil which holds it apart across the front, and it has the back, which gives it, you know, very, very dimensional stability. Your hood doesn't have that. Your hood has two sides and a top, and that's all it has. It has no airfoil. It has a dish surface here and a dish surface on the other side. So maintaining that integrity is very hard to do. If it becomes a problem in the future, then you're going to have to call us, and we're going to have to address it. I think right now it'll function, you know, well for what you need it to do. But if it becomes a problem, we'll, you know, like I said, have to address it at some time. Any other questions about fume hoods? Safety glass in the hoods will withstand an awful lot. I've seen them withstand explosions inside of here. I was telling Mark earlier, a fume hood is not 100% guaranteed that it's going to contain everything that's in there. I've seen runaway reactions blow the chemicals come up over the top of the hood. Not that the hood wasn't doing their job. I hate to say what would happen if that wouldn't have been there. But a runaway reaction like that, and the stuff was just all over the thing. It kept everybody safe, and it kept the fumes in there. But the stuff was starting to come around over the top, down the front, and everything like that. It did its job, but it's not a bulletproof container. I've seen explosions inside of these that have shattered the glass and everything like that, but still it contained, you know, the shrapnel and the material inside them as well. It is not an explosion-proof device. Anyway, good fume hood, you'll enjoy them, especially if you haven't had hoods before. And they're not to be putting students in, you know, for detention. Ready?
We're ready.
Standard fixtures that you have on this facility, these are manufactured by a company called Water Saver. They're out of Chicago, considered to be the premium manufacturer of all this type of fittings. You notice we have a different type of vacuum breaker on the tops of these. And again, the intention is that you run some tubulation down into the water here, and for some reason now the water doesn't get shut off, or you shut the water off, it doesn't siphon it back in and get it into your potable water system. The recommendation, I made a couple of recommendations, and one of them was, you notice you have your 10 ring serration here for tubulation here. I'd really recommend, these are got a hex nut on the top of these things, that you probably take these off unless you need them. And get an aerator that fits up in there. And I'm not sure if they're commercially available at plumbing supplies or whatever. A lot of times laboratory fittings are a little strange as far as their accessories. But I'd recommend taking these off, putting an aerating device in here so you can keep from having a situation like this. These are fairly deep sinks, but you can still have that problem. And the other thing is, your angelic students, if they slip a little tube on there and turn this thing on, you can shoot water the full length of this lab with ease. And not that they're going to do it in class time, but you know, it's a situation that you want to be maybe more safe than sorry.
Are there additional fittings, like we could put a
You can put an aspirator. You spin this guy off, you can just spin a regular aspirator on there with a little sidearm and aspirate down there. I'd suggest in that case, though, slipping a little bit of tubing on the bottom of that aspirator and sticking it almost all the way down to the bottom there, so you don't get, you know, so much violence out of that. You're very, very fortunate. Normally, they don't dish these sinks this deep. You've got very, very deep sinks, and usually they're only 8 inches deep, and you're, I think, 14 in these. And those 8-inch sinks, you got water all over the place every time you turn them on. But it's just a good recommendation, I think, just to save a lot of problems. The other thing, if you have any problems, you probably don't want to do it. Well, this here is loose. It would take a heartbeat for a student to, you know, just walk with this little cold water fitting or cap.
Can you hold that in place just so we can see that?
Yeah. What I recommend doing with these, you know, if you have some loose ones or you see any disappearing, these things are set up. They have 2 flat sides. They're round. They have 2 flat sides. So you can either give I'd use a crescent wrench so you don't scar them up, or a wrench that fits them correctly. You can spin them off. I would suggest taking 1 little drop of super glue, not much, just a little bit, just enough to keep them from easily coming off. I'm going to give or send to Mark it's sort of a hotline type of thing for parts and pieces for all the fittings and fixtures you have. If something happens, you know, if you need to get some different parts for in here, or if your fittings, you know, it gets harder and harder to shut them off, they keep leaking or whatever, that you can readily get those materials. And I think there's like a 24-hour hotline on those things, so very, very good turnaround.
Can you explain when you shut them off about the delay that happens and why that is?
Turn the water on. See, even here, you know, it's a little hard, but you can see a pretty good mist just running it right now. I wouldn't want to be standing around here length of time because you're going to get fairly weathered. When you do shut this thing off, you'll notice it takes a length of time before it shuts down. On a normal fitting, a gooseneck or whatever, the only thing that would drain out would be just this lateral part. The rest of that water would stay in there. This one here, it has a time delay. Once that little float goes down, then the water all slowly dissipates back down. But it does create breaks that vacuum in there so that you cannot sit there and aspirate or pull materials on a suction back out of that sink. So that's the intent. It's just a side point. I do want to address it since it's something that is on the punch list. I think you have 3 double tub sinks in your prep rooms where the fitting like this sets directly down on the pieces right in the middle. And the fix for that is to put a swivel right in here. It's an easy fix. What will have to happen, somebody in maintenance, whatever, you can usually do this by hand, or if you pad this, they can put a pretty good sized wrench on there and get a little torque, and you can break this right up in here. You'll spin that off. When you have that spun off, then you can spin this off, and you put that little fitting down in. The reason I'm saying that is because your double tub sinks are up against the wall, and you can't spin this all the way around. So you have to take this off here, and you have to have a plumber who knows what they're doing. Otherwise, don't let them throw a pipe wrench or anything on this tube here. They'll crush it.
I'm gonna stop.
You might want this on tape as well. Sometimes you get special applications. You may get down the road where you want to run an experiment or you want to do some things that requires something different out of these goosenecks than what you have. Maybe you can't get into the sink with what you want. You have large graduated cylinders or volumetrics you want to fill, and this just isn't working. You can get whatever lengths, components. You can go vertical, you can go horizontal with lengths, this type of thing. Give you some additional features. There's nothing really to be said about the gas fittings. It's pretty much standard fittings. I was telling the people earlier, one thing I did see one time in a high school setting was a kid had hooked up a rubber hose here and to here, and turn them both on. So again, a good reason to get rid of one of these. It cuts down on what he can do. The worst he can do is hook across from one to the other. If we can switch over here, pegboards, you happen to have a series of them. On this wall, you get 3 of them. Only one of them which has a sink underneath it. There's a drain trough underneath, and supplied with it is a nice little tube that is 25 inches in length. We discussed this a little earlier. I am not a great proponent of running a tube all the way down across it into that sink. We discussed maybe it might be easier to put a little, almost like a little Tupperware container. All you're trying to get rid of is just the drippings. You're not trying to get rid of, gallons of water. But again, it could be a little point of frustration. The fitting over here, fortunately, does have a sink, right underneath it. With it, you have a handheld eye wash, 2 little caps that fit over the top, and again, and these are, can be pulled out.
Is there a maintenance schedule for those in terms of how often? I'm trying to remember, there's some kind of expectation of flushing, or do you know what those requirements are?
I don't know what the requirement is there, and I think that would probably be a plumbing requirement more than it is, from our supply end, that somebody has, again, when they check your safety showers, and that should be done on a routine, that they also check, these handheld ones as well. And that should be a standard structure or maintenance that you have, and probably yearly is going to be done. But your state fire marshal, should be coming to check those safety showers, and I think that's who's responsible for doing that.
Okay, we're recording.
Okay, in the corner of each lab, with access, are emergency eye wash showers. The eye wash itself, you have eye washes around the perimeter where you have sinks, but if you pull this unit down, it automatically kicks a shower or an eye wash on. These labels, we supplied these materials. This label should be, placard should be on the wall here someplace, as opposed to hanging on the handle. So somebody needs to attach that someplace. The emergency shower, I'm not going to demonstrate for you right now, but pulling down that handle, the shower does come on. And if you notice, there are no drains. And standardly, they do not put drains in for showers. It is assumed that if you get an emergency situation and you need that eye wash or you need that shower, you're not going to be overly concerned about having water on the floor. When they do test them, they put a shroud around them in a 5-gallon bucket, and then they kick them on. If you want to test them yourself, that's the way I would do it. Get a 5-gallon bucket, set it down below, get a shower curtain, wrap it around the top of it, and make sure that the thing functions and works.
Do you know how much volume that puts out in what kind of time frame?
I don't know. I can't tell you what the temperature is set, and I think it's just strictly a cold water setting. There have been some strange situations with eye washes, and not eye washes, but showers. Modesty, for instance. They've had situations where maybe a female is not apprehensive, but hesitates about allowing herself to get totally body soaked in front of coworkers or whatever. So, as an instructor, you're going to have to face that if something does happen, and physically throw somebody in there.
Another question: when you pull that lever, it goes from on, like the eye wash, you can push it back, and so
Yeah,
you can
yeah.
actually, by shutting it, stop it.
This should
We've
stay
never
on
seen-
until somebody physically pushes that handle.
So
back
when
up.
you pull it down, it
It is
engages,
not, yeah, it engages. It's going to stay on until somebody.
and then you push it back, it'll
Push it back
disengage.
up,
Okay,
yeah.
so there was, in other words, it's not a set volume.
No,
And then
no,
it turns itself
no,
off.
no.
Okay.
The only times is sometimes you get some portable type of units that are bottle operated or something like that. Will have a set amount of time frame. But it's a good unit. It's very, very attractive the way that it's recessed into the wall. It's probably very, very important as part of your opening day curriculums with your classes is to take them through the safety features of the facility, the laboratory. If something does happen, with the dire threats of what does happen if they decide that this is a toy and not a device for safety.
I'm wondering if it wouldn't be worth doing the demo of the shower if we can figure out how to do that. So, because every kid's going to want to know what that looks like if you show it to them. That may be a better plan than sort of the whole semester wondering what will happen when we pull
Well,
the
I
lever.
suggest getting yourself a little wading pool out here.
Yeah.
Kids wading pool with getting a volunteer, get the throw something on Lyle and then let it know.
And also, do you want to have a stated dire threat before?
Oh, sure.
Oh yeah, no, it's this one's a little actually not as bad as some. Most of them used to always have the little triangle hanging down here, that looked like a dinner bell gong, that. One of the remember you've probably seen the ones that had just the bowl out there with the the two eye wash things, years ago I saw a salesman go into a lab, and he was a chemical salesperson, but he went over there and he assumed it was a drinking faucet. And I look at it, he stands there and he activates the thing, and it comes out in those two little streams, but those at that time didn't drain the eye wash either.
Oh.
He's standing there and the water is all over his shoes, all over the bottom of his pants, But anyway, laboratories can be funny places.